Welcome to Three Devs and a Maybe, the podcast series for beginner web developers and general web enthusiasts. Now, introducing your show hosts, Michael Budd, Fraser Hart, Lewis Caines, and Ed Mann.
Hello and welcome to another episode of Three Devs and a Maybe. My name's Ed Mann, and this has been my fifth trying to record the intro because for some reason the guy that I've actually got on the show today keeps making me laugh, and I don't know why, other than he's a hilarious guy. But yeah, sorry, so it's Ed Mann here with my good friend Jason Marden. How you doing, Jason?
Hi there, thanks. I'm very good, thanks.
Yeah, well, I won't let the audience into too much of the dilemma that we've been in, like going through Google Hangouts. Now we're on Skype to finally get on. It seems like I had a lot of problems with Audio Hijack. I thought that it was easy to do Google Hangouts on it, but it seems to be a bit of a pain. So, yeah, so anyway, we're back on Skype, reliable Microsoft product. But yeah, so how's your week been, sir? I mean, it's almost the end of the week. You been up to much?
It's been busy for me. Busy, doing my software development for Smartology.
Yeah, so, well, I should actually probably, really sorry, this is very unprofessional, to actually introduce you first. So I met Jason at University of Greenwich. We were both in the same year. And yeah, we did 3 years together. He had good fortune, the lucky guy, to be with me for 3 years. We were doing not national diplomas, that was BTEC national diplomas. We're both doing undergraduate courses at University of Greenwich in computer science. And yeah, really, I kind of thought, get you on the show. I've been trying to get you on the show for almost a year now. But then finally today was the day that I was able to kind of twist your arm enough to get you on. And so I suppose with the audience, how did you get into programming then?
Oh yeah, definitely. I mean, at one point I did want to become a photographer, and I also have a keen interest in psychology. So that was another avenue I may have taken. But actually, when I was at school, I would make Flash animation, and I learned to program sort of through Flash mainly.
Oh, action scripts and all that, tweening stuff and all that fun stuff.
The good fun of action scripts. Yeah, exactly. It was mainly with modifying games to perform the way I wanted them to perform, so just changing the behaviour. But yeah, when I got to university, I was doing a general computing degree, and suddenly, after a little while, I just started to love programming, especially in Java, and that's where I wanted to take my career, basically.
Yeah, so you said that, like at school, so that would be secondary school, you did primarily a lot of Flash stuff with ActionScript. Were you familiar with any other programming languages before you went into university, or was that really the one you kind of was your staple, your starter language?
Well, to be honest, at school I never actually learned any programming. It wasn't on the curriculum, which it is now, which is really good.
Which is good, yes. That is a very good thing. From the age of like 5 or 6 or something now, the kids will be being taught how programming.
Yeah, it's brilliant. I mean, obviously with the Raspberry Pi, kids and whoever can develop C applications and Python if they like. So that's a great opportunity for schools, I think. But yeah, unfortunately for me, didn't really get the opportunity to program at school. It was mainly through, I could say, a friend of mine who helped me learn a bit of HTML and JavaScript and the Flash development. I did it all in my spare time, so I wasn't too familiar with programming language before I came to university, I must say.
No, that's cool. I mean, like, I think we all have, building up websites and releasing them, and they're like your homepage with you actually were in a band. Well, you are a musician yourself, so you're in a band, so you probably had a band website and all the marquee tags and everything to make it look sprucing it up and everything. Oh, I miss those days. The work in progress little GIF animations.
Dreamweaver.
Oh, Dreamweaver, yeah, you drag and drop, the WYSIWYG of dragging and drop, but then you realise the source code it's quite insane, so then you're like, I probably really don't need to put this online, I'm sure there's an easier way. But then the Flash stuff you said, that wasn't actually in the curriculum then, that was stuff on the side that you wanted to get into with ActionScript and really like learning how the games worked.
Yeah, that was completely on the side. Nothing to do with the school. Although the school did have the application, they didn't use it, which is a bit of a shame.
So they show it to you, but like, yeah, you won't get to use this. It's just kind of like, it's there, but we're never going to touch it.
Well, we were promised, I think, in my last year of school, we was promised that we were going to do a bit of programming, but apparently the teacher didn't feel that she wanted to do that.
Solid. There you go. That's a lovely... I just don't feel like doing programming this year. Oh, dear. But then, so you got to uni, and did you like... So you said that you thought, maybe doing another couple of things, maybe photography or psychology. And then, like, I suppose then, what was it that programming kind of at university really made you love it so much?
I don't know. For me, it was the control and the ability to create things and really customize things and yeah, I really got into that, to be fair. And I just love. For me, I enjoy creating applications which help people. That's one of my passions, I must say.
I suppose the first year was primarily a Java kind of, because I mean the whole course really had a Java kind of flavour to it, didn't it? It was very either that or C#. There wasn't. I mean, there was a couple of avenues you'd have gone down to like do some C and etc. But primarily it was Java, and I suppose that must have been like your first kind of language that you got into. Wasn't only just a programming language and learning that syntax and kind of like procedural style, but also OO. Did you find it hard to kind of grasp both OO and programming? I mean, I put programming in like kind of a, in quotes, where it's, a paradigm, because normally, typically how I got into it was through Pascal, and, it was a very procedural look, and diving straight into an example of, a Java application where, to actually bootstrap the application and do a hello world, you have to make a class, then go public static void, arg, string, blah, 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 and then system.out.println. Was it quite intimidating at first, or did you really kind of feel like you got into it and you really enjoyed like the objects, approach to it?
I'd say it was, to begin with, it was a bit harder to understand. Obviously Java, as you say, being an OO language, completely different from languages such as C and such. Grasping the concept of classes, inheritance, and various features like that. It took a while to really get into, and I'm still learning and developing my skills at the current company I'm with in terms of OO, but I'd say it started out sort of being a bit of a mystery, but I'm definitely got the grasp quite quickly, I think. Because
I know that like our first what was our first year project was making like an Argos kind of ticket application type thing, like order application. I'm sure that was something along those lines, or was it a penny? It wasn't the penny one, the penny collection thing. It's all these different examples that you get, like throughout the years of university.
Yeah, you get a lot of examples and applications you create, and I find they're a lot more trivial to what you have to deal with in the real world.
So yeah, that's actually a really good kind of segue there, because I one of the real reasons why I wanted to get you on was because I feel you've got, a really good place to talk about this. Is kind of that transition from university programming to real life programming. Do you feel, like, I suppose, what was your firstly, what was, your favorite course? What was your favorite lecture course, or I suppose you say course, at university? Was it the programming ones, or was there any other one that you really enjoyed, like the UML and the system architecture and system? I think it was called system building when we were there.
Yep. Yeah, system building. Mainly it was the programming ones. The UML ones were good, but interestingly, UML isn't as highly sought after anymore.
They really did push that as kind of, you have to design up front these massive diagrams before you go and build something, and turns out it's the complete opposite in the real world.
When you got like the agile methodologies and such, you don't tend to focus on UML diagrams. So it was an interesting course, and it was interesting to learn various bits about networking. But for me, it was always programming, and mainly Java, because we, as you remember, we did learn C#.
We did indeed,
which is obviously very similar to Java anyway. But it was good that for one of our projects we combined. We got Java and C# to talk to each other via SOAP. That was actually probably to me a lot less trivial than most of the stuff that we did, I think.
That was a lot more, kind of polyglot approach of using, I think, what was it like? We had a JSP application, and then we had a ASP.NET application. And I think we had to interface between, with SOAP using a, lovely simple object access protocol. Which again, I mean, actually saying that, I mean, have you seen that in the real world being used? I think I've used it once in one project, and that was it.
Well, I mean, actually, funny enough, we discussed it the other day, because we were talking about, obviously, REST is sort of the main way of getting two applications to communicate with each other. And obviously, REST is pretty big now. And obviously, when we were at university, they pushed SOAP quite a lot. And to be fair, I haven't really seen it since. So I do wonder whether companies actually still use SOAP, to be fair.
I think it's got a lot of backing. I mean, the WSDL, the idea of that, the directory is kind of really a good idea. I think it's very good for, I mean, I remember it being, when I was using it, because the funny thing was actually using it was a ASP.NET SOAP service, but I was interfacing it with it using PHP, which, obviously isn't really its kind of bread and butter, language to actually interface with it, because really what it's made for is kind of big IDEs that, you download the skeleton files that then you're able to interface with, and then it does all the conversion down. And I mean, whereas now RESTful interfaces are so much more, kind of encouraged, because really it's dealing with the web as the web is. It's handling, endpoints and handling the different HTTP methods and dealing with embeds and HAL and all this stuff. And really, I mean, at your workplace, do you deal a lot with different services? I mean, I'll put microservices, or and how do you transfer? Because primarily it's a web company you work for. Web company dealing in contextual advertising, and we have a ton of micro services. Mainly, we use REST with JSON mainly. As opposed to XML. Not that we're against XML, but we primarily use JSON throughout the applications. And generally we separate our GUI and sort of web application from the actual API logic that would perhaps retrieve data from the database. So, at uni, what skills then from the transition from uni to work really kind of helped you? Because I know we're saying like the UML really wasn't, if you could go back in time, really, I suppose this is kind of looking with 2020 vision and think, what things would you have wanted to learn at uni, or what would you have wanted to know exactly when you got out of uni? What would you want to know? Really, what are those things?
Yes, it's a good question. I'm happy that at uni we had project management lectures, which discuss things like Agile. That was very useful because I didn't go into an Agile company without knowing the essentials. But for me, I mean, I've had to develop skills in test-driven development, so TDD, and pair programming, which sort of learn about when you discuss extreme programming. So I think those were things I would have liked to have learned probably at uni, I suppose, because they are extremely useful.
Yeah, I mean, and it's a funny thing, because I mean, the way I kind of took uni was, it was really, you were there not only for the course and for the end game of getting a degree, but it was also the fact that it was giving you time to actually go off and explore your own learning other things. And I think for me, pair programming would have been a really essential tool, because very much like at university, you're kind of we're all very, because obviously it's grade centric, it's grade minded, copying, cheating, etc. is bad. But in the real world, when you're dealing with projects, the help you can get is invaluable when you work together. So having pair programming, I think, may have been a very good kind of, maybe a good thing to at least work, kind of work on and dealing with that. And, I think that obviously then works really well into TDD, because, I mean, I don't know, whether my whether my lecturers and stuff for the project management courses weren't teaching the right things, but for me it was very much kind of a waterfall model they taught me. I didn't get a grounding at all in agile, an XP or anything like that. And this has been around since 1999, and we're still kind of teaching the waterfall models and stuff like that, and building up front XML, building up UML diagrams, your use cases and stuff like that. And one of the funniest examples I probably have is that one of the actual, you did system building 2, wasn't it? I think, was it called system building 2, or did you get out of there as quick as possible?
I got out of there. It's not that I didn't like UML diagrams or whatnot. To me, it's probably the way it was taught, actually, to be fair. But a lot of the UML was being taught was quite traditional and I think outdated.
Well, that's it. And I think what my example is that so in UML 2, UML 2 of course it is, but it's system building 2. What we had to do is we had this contrived example of a bicycle machine system, and we had to model this, and we modeled it first. We watched in Teams, model it first in UML. Building up, your use cases, your system diagrams,
yes,
whatever they're called, sequence diagrams, all that stuff, and then you would build it from that. And it turns out, obviously, that when you actually go to put, your finger to the keyboard and start typing out code, you're like, this needs to change, and it doesn't go to the plan of the UML diagram. It's very easy to draw pretty pictures, but then once you've actually got the implementation in front of you, you're really dealing with a different beast. So having UML diagrams that are for aids may be helpful and may be good, and I really think it's kind of, for me, very much the fact of, are you getting your intent across to the person? Using these diagrams as a good aid sometimes to get that intent across, but it's definitely not an idea that I can draw out a UML diagram and that person's going to be able to implement that from that without any problems. I think it will definitely make things easier because it's you're going to be, probably to make these diagrams and stuff, you're going to be talking about a lot of things such as DDD now, TDD, BDD, these kind of things where you're very much talking constantly, having good dialogue with the actual customer. These diagrams will then give you a lot more insight than just writing a tech spec out. But I still think that kind of, maybe what would be better is if we had done a smaller REPL loop, and used these diagrams, but not to the extent of you first got your diagrams graded, then you built the system. It felt too clean cut, too much like, this isn't how real world works, is it? Because if it does, then there's a reason why these books are out, because I knew about the Kent Beck book, the Extreme Programming book, and I knew about these things thinking, everyone frowns upon, waterfall model and these structures in the real world. Why are we getting, why are we kind of, being, advocated on it? And that then makes you, kind of think, if they were to build these programs, our lecturers and stuff, would they have used these methodologies, or would they have actually gone with what really works? And that is, small feedback loops, the agile approach, the extreme programming approach, really.
Yeah, you'd like to think that they'd worked at companies that were agile or on the same sort of level. And also, when discussing UML, I don't think it's all bad. Obviously BDD is very good as well. It has use cases similar to the way that you'd write them rather than you draw them in UML. But we still use some UML diagrams, sequence diagrams, for examples, perfect, and use case diagrams, I think, are still very good.
So how do you use them then? Do you go into the nitty gritty detail, or is it very much high level bird's eye sequence flows? Like, this is going to log in, but I'm not going to give you the parameters, or there may be a service in between that, just showing the flow, kind of the flow of data.
Yeah, I think it is kind of high level. It's kind of more conceptual, more for the CTO to see and go, okay, so that's how we could do it. Kind of plan it out, because obviously, as you said before, with any other sort of diagrams, you're going to be constantly revising them, which isn't a bad thing, but obviously it can take time if you got
Well,
someone dedicated.
it's the thing like comments in code. It's it's external things from the code that need to be updated that will get out of date if you don't keep on them. And if someone thinks, oh, that sequence diagram is related to the current project, it's like, no, that's all changed. Then it's like outdated code comments, and maybe, yeah, I mean, it is keeping them in date. And it is interesting you say that CTO, you give them to the CTO then. So is your CTO code minded, or does he prefer kind of looking at these models to get the full, the grasp that he needs?
I'd say he is he's less code minded than he used to be, but he likes to kind of see kind of in a way how we'd implement it, because obviously from that he can predict. Well, he can prioritize tasks and work out what needs to be done. And I think he'd like assurance. Really, is mainly what he's after.
No, I think that's good. I mean, that really is where I think these diagrams work out really well. Is kind of an overview of this is how we're going to solve the problem in broad brushstrokes. But when you get to the fine grained, and that's really where the course was. I mean, the joke is I can't remember what the package was called, but one of the UML packages that you draw all your diagrams, and then you can export the Java code, so it would generate the objects for you. Yeah. And I just think that isn't how it works, because these are two, what's the point then? Then I kind of go to, what's the point in having the diagram? Why not just have the code? The code is the running implementation. The code is the documentation then. If you're going to that finer grain level, you don't need to do that. So, no, it's really interesting. I kind of went on a bit of a tangent there, but no, UML diagrams have kind of... And I mean, it's interesting that you actually used them, because I haven't used one since I left uni.
Oh wow, really? Okay, well, yeah. I mean, we don't obviously use them for every project and every single thing, but so one of the good things about working in a team is you can go up to, say you've got a problem, you can go up to a whiteboard, and you can sort of just draw a use case. Because I mean, use case really all it is a stick man with actions. It is really all it is.
Yep.
And again, with sequence diagrams, not hard to draw. They give you some good direction. They might not be 100%, but it's good for starting out, I would say.
No, whiteboarding is amazing. Whiteboarding is the thing, but especially in teams and even on your own, just having that place to be able to just drop, kind of like, chuck brain dump, kind of all these things, and being able to kind of express. And I suppose maybe then, I haven't used UML in its strictest sense since I've left uni, but I have taken parts of it, like, kind of responsibilities and stuff like that, but probably not categorize them as, like use case diagram, but used it as long all these tools are there just to get your intent across and to design a good product. And I mean, there's things such as, like, do you remember making CRC cards? Do you remember that? There was one thing we had to do. We had to build up the class responsibility. Hang on, here I've got the name of it again. Here it's class responsibility collaboration card. So on top of the card is the class name. On the left, the responsibilities, and on the right, the collaborators. Other classes, which this class interacts to fill its responsibilities. And I suppose, I'm saying that maybe in a, kind of a blur way, but it's funny that Martin Fowler actually, says that. These CRC cards are an alternative for UML sequence diagrams, and collaborate. Working out the collaboration and stuff and how they all pair together. I mean, I suppose for me, the nice thing about sequence diagrams would be that you can know the time of collaboration, and the flow of when it goes back and forth. And I suppose what I'd like to know, and it is also, well, it's funny actually. I mean, it's actually recommended by like Ken Beck and stuff as a teaching tool. And it's also popular in front of extreme programs. So class CRC, I've never used one of these since leaving university. But maybe, this official kind of definition of it would be a good idea, kind of bit in a pack of cards and being able to write these things out. I mean, I typically, whiteboard a lot of things, a lot of classes and how they're going to flow between a lot of them. But eventually what happens, I find, is you get into, once you've got a kind of an idea, then you just hit the keyboard and you start prototyping. And I mean, I know that you're saying about TDD, and I probably don't do TDD as enough as I need to, as I should do, I suppose. With my upfront tests and then implementing it like that. But I have definitely, even this week on a personal project, I found that doing TDD in testing up front really does help guiding your design by test really does help mold a better implementation. Or an implementation you never would have got there unless you'd done it through tests first, because you would have made it more complicated and stuff like that. And I suppose, how do you do TDD then at your work? Because I know that you're very much kind of for it and with it on a day-to-day basis.
Yeah, TDD we're not, I wouldn't say we're strict with. Well, we're fairly strict with. But yeah, for us it's about obviously increasing code coverage, which is obviously pretty critical to us. But also, as you said quite rightly, it can simplify the design, and it can help you cover all bases. For example, you have your positive cases and your negative cases. As simple as like checking if something's null, does it throw an exception? That sort of a certain you can plan out, and then from that write your code, and obviously it helps you to refactor as well. And we use it. We're constantly doing TDD, and we do it in pairs as well.
So how does that work then? Do you both write the tests, or one of you write the test, one of you implement? How do you kind of play that game of tennis?
Okay, so interestingly, one of the members of the team goes to code dojos in London, where obviously you pair with someone you've never met before and code away. And so the way that they do it in the code dojo is someone writes a test, the other person implements it, and then you swap. That's and you keep going through this. So you're constantly engaged. The other person can obviously comment on, okay, maybe you should consider this, or possibly we should write a test for that. And you both basically are directly involved with both writing the tests and coding. So no one's left out of the loop. No one's sat there thinking, please, can I code now?
Yeah, that's it. Can I be it's like, it's my turn, tag me in, please.
Exactly, yeah. So you're both actively involved, and I think it's a good way to do things. I really do.
No, I mean that's a good. And at work, then, like how does it work at work? Do you kind of look at problems that you're dealing with and then say, okay, I think this is going to be, because I do feel, I know that obviously huge TDD advocates, will say that TDD is right for everything. But I do feel there's there's better suited, better suited problems for TDD. And do you do that way, or are you very much blanket, everything is TDD? Or if you do kind of, I mean, there was I was listening to a Full Stack Radio podcast a couple of days ago, and one of the things was, well, kind of driving through TDD, like, when you're halfway through a loop, kind of, a cycle, sorry,
Yep.
What do you, say like, oh, bugger, I've kind of got this bit wrong. I know I've got this wrong. Do I revert back and delete all the, and go back to the beginning, where it's back to red, rewrite that test and then green and that, go back again? Or do I, have to go all the way through it, finish it and then go back? Because I think, when you think with changing things and stuff like that, you can get yourself in a bit of a mess with TDD. I mean, that may be my just saying, I suppose, like, how do you do it? Do you TDD everything, or do you only TDD the bits that you feel need that kind of care?
I mean, TDDs, we try to do it throughout all of the projects, but I do mean there are certain scenarios for it, and there can be parts. I mean, so TDD is something that can be quite of a steep learning curve, because it's
a really hard discipline, I think, to grasp, and I think I'm still very much trying to learn it. I
mean, it took me a while. So so the CTO that we got currently now, he wasn't at the company originally. He joined, I think it was a year or two into when I obviously started working, and he introduced TDD to us, and For me, at first, it was like, wow, you have to write your test first, and you have to think about this before you actually code. It was a completely different way of thinking of things. And as you mentioned about, you can get yourself into a mess. You certainly can, because the one thing you don't want to do is overcomplicate things.
That's it.
So what some people do is that they'll write. I've had the same problem. I've written a test, and then I've gone and written the implementation, write another test, and I've now decided that, okay, that code actually could be moved to another class, which is kind of premature, because now that means that I can't finish the whole of this test class until I move to that test class and finish.
You have to go through the you have to finish it off, spend that time to finish it, then hit the refactor phase, then do the work.
Yeah, I think you can definitely get yourself stuck in that.
I mean, are you strict to that? I mean, how do you work with it? Because I know that there's like almost three ways you could go. You could either do the change there and go like, okay, this is broken. I'm killing, Kent Beck's killing me, looking down at me, looking down at me, because obviously he's up in the sky, this Kent Beck TDD machine, looking down, saying, oh, I can't believe you've done this, and, Uncle Bob's like, why are you doing this? How dare you change, without doing the religious red-green recycle loop. And then, or you go back and you say, okay, well, everything that I've done for this, this cycle, I'm going to get rid of and delete, and you start again. And you then, say, refactor, and then you kind of do it all and you re-implement it a whole again, but with the way you were going to do it. Or do you work through the problem to the end and then do the refactoring? How do you do it? Or is it kind of as per, the use case that you've got at that time?
I think it's a mixture. You're open to changing the way that you do it. I mean, obviously obviously, so you begin with a failing test, and then you get it to pass the simplest way you can, i.e. return a hard-coded value. So that step you could maybe miss. Sometimes it's not necessary. And then obviously you implement it to pass correctly and then refactor and...
Yeah, because in the book, in the TDD book, it was very interesting. That was one of my... Sorry about I've completely gone off, but there was one thing that really made me think a lot about TDD was I used to joke and say, well, yeah, what's the point? Okay, I've got a calculator, and the test is 2 + 2, and I return 4. I'm like, ha, 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 and I'm like, well, that's my first test done. Now I need to do another test. And actually, it's in the refactoring stage of that test that you should think about actually changing it from 4 to actually, no, this now needs to deduplicate, because technically you're duplicating information there. You've got the 2 + 2, and also then you've got the 4, and those implicit are actually duplications, and that's a refactoring. And that really opened me up, saying, actually, okay, so refactoring step is really crucial and really important, and really, I think it's actually the hardest part of TDD, in my opinion.
It's definitely one of them, because obviously once you've got it to pass in a maybe a not messy code kind of way, but you've
you've done all the sins. You can sin as much as you want, is what Kent Beck says. As long as you can get that to go green, you're fine.
Yeah, you can, and then obviously after that, you need to make sure that
then you need to fix your mess.
Yeah, exactly. If you can make things abstract, or if you can move it to a separate class, or basically, separation of responsibility and all that, you have to come back to, and it is an art to do TDD. I do use it in my personal projects as well, which to a lot of people is a surprise, because with more trivial kind of examples and applications, it doesn't particularly work, I would say. But with enterprise software, I believe it does. And also, I would say one thing that helps, one thing that goes hand in hand with TDD would probably be the necessary evil of mocking.
Yeah, that is a really interesting... what is your opinion on mocking? Are you a mockist or a classist?
So yeah, I think sometimes... So mocking is useful. It should be used if it can be used. But if you mock too much, what you find you're doing is your tests are just a complete mock of the implementation. So
You're
it
testing
means
the
that,
mock, not the actual implementation.
yeah, you're testing the mock, and it does seem wrong, and I have had to fight with the idea at work at times. But where mocking can come in handy is that in the refactoring step. For example, you want to move some code to another class, but you don't want to do the implementation quite yet. You would obviously mock the class, mock the return value. That will get your test to pass, and then do your implementation. So mocking can be useful, but there is a fine line.
I think, yeah, and I think mocking kind of is a really bad word to use, because
Yes.
the real word is test doubles, and
Yep.
test doubles are split into a couple of types, and you've got your dummies. And your dummies are the dumbest of the lot. All that does is abide by the fact that, yeah, I'm just here because I don't do anything, but I'm here just to abide by the fact that, your parameter list requires me. Irrelevant, kind of things. And it's never going to be used, and it's only there just because the compiler needs it or the interpreter needs it. Then you have your stubs. And your stubs are, as you were talking about, like return, just a known value. So a stub could return for 2 + 2, 4, or it could have, be a bit more clever and say, oh, if you pass me the, the email address cheese@email.com, I'm going to return you cheese. But if you pass me the word bob@email.com, I'll return you Bob. It has a known out return. You know what's going to be returned, and it's probably going to be in a lookup table or something, or just a hard-coded value in the stub. Then you have your spies. And your spies and your mocks, and you actually have mocks, and that's where it gets into it, because you've got spies, mocks, and then you have your fakes. Fakes are a real implementation, like an in-memory one, that could actually even be used. Sometimes people find, actually, I don't even need, to have a data persistence store here. I can just use this in-memory one or something. And, a fake is exactly like the the implementation you're going to use in production, but maybe you've taken the fact that, you speed, you want it to be quicker, you want it to be, easier to test, etc., like that. But I suppose spies and mocks could be used and can be used almost in the same way. It's where they get their assertion from, and it's where they get their validation from. So I suppose, how do you test? Do you test just with using... Because I think then we just have things like mocks, and you've got mockery in PHP, you've got like JMock, I think, in Java, and things like that, where you're just like, all right, I'm going to mock everything, and really, I'm just going to use the blanket term of mock, even though I mean this is actually a dummy, this is a stub. Are you quite explicit with your naming of these things? But I suppose with a mocking framework, you can't really be, unless the framework really does kind of lend towards that. You're going to get into, oh, I expect this value and return this value. And then you're like, oh, actually, that's a stub, really, but people just assume, oh, it's just mocking stuff. Because then when you say, oh, and it should only be happening once, and you're like, okay, that's not a stub anymore. That's a mock. That's actually asserting there's an action flow on it and stuff. And you're saying, okay, that's actually calling, that's actually, cool messaging and, message passing going into the OO stuff of like, actually, hang on a minute. So I suppose, sorry, I'll kind of like, again, a massive tangent there, but what do you do? Do you split them up into the 5 categories, or do you just say I'm mocking this?
We use Makito, obviously Java-based library, and
hello, hello buttons.
Oh, sorry about that. That'd be buttons. So we use Makito, and really we use stubs more than anything. So again, I'm going to use mocking the return type, or stubbing the return type. But we also, use mocks in the way that we validate how many times a method's been called, or
you imagine validate the flow, and that this is going to get called and stuff like that.
Yeah.
And when it gets called, and why it gets called, and what it gets called with.
Yes, I think also I'd like to mention about obviously, with injection. So with injection and annotations in Java, you have the annotation. You have the annotation. You have the annotation inject mocks. Now, what this means is that every class that has been defined and every method that has been called, you have to mock now. So
really?
you're forced now to actually mock everything.
So say you've got a class A, and in the constructor I require a B and a C.
Yes.
So what does that mean then? It means then that to instantiate it, I need a mock. I couldn't just use a dummy. I need an actual real mock.
Yeah, you'd need a mock of. Well, no, I think you can use a dummy as well, but the way I've seen it mainly be used is that you create a mock for B and C in the constructor, and if B and C are, if they're calling methods of B and C, if B and C methods are being called, you also have to
mock
stub
those. Yeah. So, because that then gets me into, again, with these mocking frameworks, they're great, but I actually prefer the real classes. I know it's more lines of code, but I prefer, there was a really good tweet a couple of days ago where it was like, if you need to mock a concrete implementation, you're doing it wrong, because, really it should be an interface that you're mocking. An interface you should be, either stubbing and stuff like that, because what I'm essentially doing, because one of the beautiful things about Ruby and stuff like that is you can monkey patch, so say, I can use the real implementation, but I can just override the save method so it doesn't actually do a save, or it does a spy instead, or something like that, and that's great, that's nice, but it's not really to the form of actually, maybe your design there, maybe you should have actually abstracted out the idea of, well, this is this is a persistence. This should have a persistence, and you should use composition and build it up that way, and you should be able to say, okay, I'll pass in my persistence implementation, and for the test, actually, I'm just using this spy persistence because I just want to know if it gets saved, and, for me, that makes more sense than this whole trickery of taking advantage of the fact you can override methods and stuff like that, and because another way that you get around it is you extend the class and then you override the method. So you don't have to do monkey patching, but you can still do, we're using inheritance, etc. The idea of monkey patching. But yeah, so with you, what do you feel? Do you feel the same? That you feel that, if you need an implementation, if you need to mock it, and it's a concrete implementation, it should really be an abstraction instead. I think I'm making sense. I'm not sure. It's quite late.
It kind of makes sense, but I'd like to say that with mocking, there's certain things that you should or will want to mock. Like, for example, you've mentioned it already, the database level.
So again, when you say, this is the thing, like when you say mock, you mean like test double.
Yeah, like a test double, or yeah, it is a test double, really, but yeah, it's quite confusing with all the amount of terms you have for.
Well, that's it, because I think mock, again, because you're mocking and then it's a mock, and I think they said that the people who actually made the term mock didn't actually know that it was going to get used in this way, because it's kind of become a blanket term where actually test doubles, I'm going to use a test double here because I don't want to hit the real the real implementation. I don't want to have to go through the mill of checking to see if Postgres or MySQL actually has this entry. I just need to know if it actually even got called. So I'll use a spy, or I need to know how many times it would get called. So I'm going to set up front, okay, I need to know that this gets, called up front, this time, and that'd be a mock.
I think so. I think the database, I think if you have control over that database and your app can talk to it, I would say integration tests are probably better, where you can obviously insert data into the database, do your assertions based on that, and then tear down. I think that's a good way of using.
Yeah, that is the great way of what is it? Set up and tear down, and then you really roll back all the changes that you've done to the database. But exactly. I think you can then go over more kind of more fine grained and say, okay, well, I'm going to do a contract test to say, okay, I need to make sure that this, when I insert this into the database, it comes looking like I'm meant to, it's meant to look. And then anything else could just still use a test double, because I'm sure that the test that I'm doing for the contract is working. So in essence, everything that is used in my test double will work now, because that test is working, if that makes sense, is passing. So you're not having to always hit the database, all the time and assert that, because you've got one test that says, look, if you're going to persist this, if you store this, it expects it to be stored. Now I know that implementation works. It works exactly how I want it to work. I don't need to in all the other tests, even if it's integration tests with integrating between different, bits in the system, need to know. I mean, once you get up to the level of functional tests and stuff like that, it's more kind of, I want to now test the whole thing. And then when you want to get acceptance tests of saying, okay, does it do what the user actually wants? Then you also would probably want to do the whole, the whole story, the whole way through.
Yeah. I mean, obviously, if one of your user stories was given, given an API, well, not even an API, given a user logs in or something, and behind it you've got an API for authentication or whatnot, then you're going to want to do the whole user logs in to the point where it calls the service, gets a response, and user logs in, successful kind of thing. So that would be sort of a full scale. Well, that's more of a system integration test, I suppose.
I think testing is such a. I mean, it'd be really cool to get you on again, man. If you're up for it, like to do a full episode on just testing, because I think like we've kind of the whole conversation is kind of then drawn to that, because I think definitely in my eyes you're very much into your testing, and at work you're very much kind of into that. And I suppose work-wise, like what's your stack at work then? I'm assuming, I mean the audience probably assuming it is Java based.
It is Java based. Yep, it is Java based. Our microsystems run on Jetty, so we use Jetty. We use MySQL. We use RDSs and RDSs, which are MySQL based, and we're very much in the Amazon infrastructure with our servers and such.
And how do you what's your infrastructure? Yes, your infrastructure is like Amazon, and how do you orchestrate and deal and provision your servers and stuff? I know that you've got quite an interesting kind of setup for that.
Yeah, we're setting up servers and as you say, provisioning. We use, and I'm sure some of the audience may know, Puppet. So we use Puppet to install the applications and set up directories and all that. And obviously, if we're deploying, we'll use Jenkins. And we use for deployment. We're currently using Fabric scripts, which I don't know.
Yeah, so what are Fabric scripts then? Are they similar to Ansible? Kind of like it just goes down into SSH calls, or?
Yeah, I mean, I don't know Ansible too much, but essentially what it is it's a Python script which has a ton of helpful methods for SSHing into servers, uploading artifacts, tarring them, whatever you want, really. It's probably a bit like what you said with Ansible, really.
That's really cool, man. And how's your experience been with Puppet? Are you enjoying it?
So we got introduced to Puppet through a colleague of mine, which has now left. So you can imagine
they ran away, and now you're like, crap, got to deal with this now.
Well, so they were the ones that set it up, and I guess we didn't know too much about it when they were setting it up. So we've had to kind of learn it more, I'd say, since he's left. I think the thing is, Puppet is good for what it does, and it's probably the best one out there. You've got Chef and various other ones, but Puppet seems to be a winner, I would say. I'd say the thing is, it's not whether it's bad or good, it's whether it is done correctly. For example...
it's whether you use it right. Don't blame the tools, it's how you use them.
Yeah, I mean, I would say Puppet is a similar thing to OO, where you have modules, and your modules should be generic. So they shouldn't be specific or application related. So it shouldn't be, my app Tomcat setup or my app Nginx setup or whatever. It should be modules which are very much,
reusable and good abstractions.
Yeah, reusable. Exactly. I treat Puppet the same way as I would a Java project, in a way. Obviously completely different, but it shares similar things when it comes to modules, and modules I would say as like classes, for example.
That's really cool, man. And I mean, I suppose like the last question I do have for this episode, because we're almost at the hour mark, is what would you say to people coming out of uni now, and they're looking for their first programming job. What kind of things would you say? What kind of helpful advice would you have for them?
So I would say that before they go find a job, to research, as I said, TDD, paired programming, agile methodologies. All these tools are pretty much what the industry wants, and I think if you get a head start, you're definitely going to be on the right track, and obviously build some sample applications and whatnot to get used to it, and obviously beyond that, look into more DevOps style, but look into HTTP servers and all these things I think will be crucial in the job that they get after uni, really. So I think fair enough, uni's finished. You can be happy. You get you're set up to go for a job, so you think. But
and then you realise that you're constantly learning, and really the learning starts when you're out of uni, and then it's like real learning, real world learning.
Yeah, and I think I can understand universities can't teach you everything. Unfortunately, they give you the fundamentals to get
started
for you to sort of develop. And one thing I'll say is, as a software engineer, you're constantly going to be learning. There's not a day where you don't learn something new. That's actually probably one of the best things about it.
It is a constant changing, and you're always going to, even if you have a really crappy day, you're going to probably have learned something new. I really take that as well.
Yeah, I'd say, you can learn about entity Java beans and things like that. You can learn about EJBs and enterprise Java solutions at uni, but I also say don't expect every company to do it that way. But yeah, just as I say, just keep learning, keep researching in your spare time. Definitely, set up GitHub or Bitbucket projects.
Yeah, I mean, have you got any resources? Anything that you kind of daily check? Are you a Hacker News guy? You're a Reddit guy?
Yeah, sometimes Reddit, sometimes. Lifehacker has a little bit of a section on programming, from what I remember. And yeah, just if you encounter terms you don't understand, that maybe your program friends that also have a job, talk about. Don't be afraid to not know it. Just research and find out the term. And if a lot of helpful resources are out there, like as you mentioned, Kent Beck resources. One thing I would definitely say, and this is hopefully something that Ed agrees with, I would definitely say Clean Code and Clean Coder.
Yes,
one of the
plus
best
one
resources.
to that, definitely. That changes the way you look at programming, I found.
Yes, it's changed definitely the way that I've programmed, and I think I've become a programmer for reading that. There's plenty of other resources out there, like the Pragmatic Programmer, but I definitely vouch for Uncle Bob.
Absolutely. Well, thank you very much for coming on the show, man. Really appreciate it. It's been great having you on, and finally having you on. And hopefully this will be the first of many, because I feel it's gone really well, and I'm sure the audience have loved listening to your background and like our discussion on testing. Yeah,
no problem. Yeah, I've enjoyed the chat. Definitely enjoyed the discussions, and I'd definitely be keen to discuss more on another podcast if you'd like.
All right then. Well, audience, this is the end of 3 Devs and a Maybe for this episode. Yes, see you next week. Bye.
Bye.
You've been listening to 3 Devs and a Maybe. You can contact us at contact@3devsandamaybe.com or follow us on Twitter at 3 Devs and a Maybe.